We are now starting Chapter 11. Chapter 11 starts talking about theorems using lines and angles. So in section 11.1, we're going to talk about lines and angles. So I want you to open your textbook to page 653, and I want you to look at the gray box in the middle of the page. We didn't do the solve it, so we're going to skip to the essential understanding. In this lesson, you are going to explore relationships of non-intersecting lines and planes. Your essential understanding is this: not all lines and not all planes intersect. So taking a look at the key concept in the middle of your page, you will notice three vocab words: parallel lines, skew lines, and parallel planes. Now, parallel lines is something you've done before, but I want you to make note by looking at your diagram what they look like. So parallel lines are coplanar lines that do not intersect. The symbol, and then it shows a symbol, means is parallel to. So if you look at the symbols column, let's look at two parallel lines. It says line AE, so I want you to find line AE, and line BF. You would read that as line AE is parallel to line BF. The second example is line AD is parallel to line BC. Now I want you to look at skew lines. This is new. Skew lines are non-coplanar. Underline that for me, non-coplanar. It's important that you know that skew lines are non-coplanar. That means they do not lie on the same plane. They are not parallel, and they do not intersect. It's a little tricky for some students, but take the time to look at where these two lines are. So the example it gives you is that line AB and line CG are skew. So find line AB, find line CG. And then make note that they are not on the same plane, which means they're non-coplanar. They are not parallel, and they do not intersect. The third thing is parallel planes. Parallel planes are planes that do not intersect. So for example, plane ABCD, that would be the red plane at the top, is parallel to plane EFGH, which is the red plane at the bottom. So you'll notice that they don't intersect, but they are parallel. So at the bottom of the page, it says a line and a plane that do not intersect are parallel. Segments and rays can also be parallel or skew. They are parallel if they lie in parallel lines, and skew if they lie in skew lines. All right, now I would like you to look at this example. We are on the top of page 654. This is problem 1. It's not the got it problem, so you do not have to write all of this down, but I just want you to pay attention. You will see that we have a rectangular prism. So in this rectangular prism, we have to assume that lines and planes that appear to be parallel are parallel. So we're going to start with A. Which segments are parallel to segment AB? So let's start by naming them all. So AB, segment AB is right here. So what segments are parallel to this? Well, we could say segment CD, or we could say segment DC. That's right here. We could say segment EF. We could also say segment HG. So all three of those answers are what we need to put for A. You can't just pick one because it says which segments are parallel. We have to name all of them. In B, we have to figure out which segments are skew to CD. So here's CD. Now remember, skew cannot be in the same plane. Okay, so for example, this is where, and they can't intersect. So let's look at it. DC is right here. Would CG be skew? No, because they share the same plane here, and they intersect. So that would not work. So CD, well, HG, that's parallel, can't be parallel. EF is parallel, that wouldn't work. So can you find one? AE would work. So segment AE, not parallel, non-coplanar, and they don't intersect. We could also say segment BF, that's over here. We could also say segment EH, and we could also say segment FG. That does take some thought to look at because you have to realize, okay, this line's going this way, or this segment. This CD is going this way. So they don't intersect, they're not on the same plane, and they're not parallel. All right, and C, what are two pairs of parallel planes? Two pairs. So we could say, I'm going to shade them here blue. So here's a plane on top. Here's a plane on bottom. So let's name them. So you'd actually have to write plane ABCD is parallel to plane EFGH. The other one I'm going to do in green, you could say, I'm going to do it in green, and you can see I colored it in green. We could say plane. Now, I'm going to trick you here. I'm just going to say ABF. Is that the green plane over here on the left? It is. Because remember, you have to use a minimum of 3 points to name a plane. You could have also said plane ABFE. So that also would have worked. Is parallel to plane DCG. You could also say plane DCGH. The last question says, what are two segments parallel to plane BCGF? What are two segments parallel to plane BCGH, or F? BCGF. So I'm going to color that purple. That's the back part of this. It's kind of hard to see. So give me two segments that are parallel to that. You could say segment AD, and that's right here. It's parallel to the back, and segment EH. So now we're going to look at the got it on problem 1. In the figure in problem 1 shown at the right, which is now in your book, which segments are parallel to AD? So find AD and figure out which segments are parallel to that. If you did it correctly, you will notice that segment BC, and segment FG are all parallel to AD. B. Now look at part B. Explain why segment FE and segment CD are not skew.
Planar, they don't intersect.
So, first of all, you could say that they're parallel. So they're parallel, and therefore they cannot be skew, or they're not skew. You could also say that they lie in the same plane. Now you may ask, wait a minute, how are they in the same plane if they're not like resting on a side? Because there is a plane that if you actually drew it would go diagonally through the box, through E, F, C, and D. So they're actually also coplanar. So you could say they're not skew because they're either coplanar or because they're also parallel. Part C, what is another pair of parallel planes? Well, you could say plane BCGF is parallel, but that's the back wall of the rectangular prism, is parallel to the front wall of the rectangular prism, which is plane ADEH. D. What are two segments parallel to DCGH? That's the right wall. So two segments that are parallel could be segment AB and segment EF. All right, now turn your book to page 655. This is going to be fun. There's a lot of stuff here. Essential understanding. When a line intersects two or more lines, the angles formed at the intersection point create special angle pairs. Some of these you've actually done before in 6th and 7th grade. A transversal is a line that intersects two or more coplanar lines at distinct points. The diagram below shows the 8 angles formed by a transversal, line T, and two lines, L and M. It's important that you notice that L and M are your lines. Your T is what crosses both of them, which would be your transversal. From that, you have exterior angles, and you also have interior angles, which are noted in your diagram. But you form 8 angles, and you've done that before, kind of in 7th grade. So notice that 3, 4, 5, and 6 lie between L and M, therefore they're interior. Angles 1, 2, 7, and 8 lie outside of L and M, therefore they are exterior. Pairs of 8 angles have special names as suggested by their positions. And here are a whole bunch of different angles. Under your key concepts, alternate interior angles. Alternate means every other, and interior means on the inside. They are non-adjacent interior angles that lie on opposite sides of the transversal. So just look at them. Angle 4 and angle 6 are alternate interior. Angle 3 and angle 5 are alternate interior as well. Same side interior angles would mean interior angles that are on the same side of the transversal. So angle 4 and angle 5 are all same side interior angles on the same side of transversal, and angle 3 and angle 6 are same side interior angles. Corresponding angles lie on the same side of the transversal and in corresponding positions. It's like the same position. So angle 1 and angle 5 are corresponding. Angle 4 and angle 8, angle 2 and angle 6, and angle 3 and angle 7. Alternate exterior are the same as alternate interior, except they're on the exterior, not the interior of your lines. So angles 1 and angle 7 will be alternate exterior, and angle 2 and angle 8 will be alternate exterior. So let's look at the got it problem at the top of page 656. Use the figure at the right. What are 3 pairs of corresponding angles? So let's just go through some of our definitions so far. All right, so now let's look at what we have here. We have 2 lines, M and N, that are cut by a transversal R. 8 angles have been formed. Corresponding angles are angles that are in the same position. So we just want to name 3 pairs of corresponding angles. So we could say angle 1, I'm just going to pick angle 1, angle 2, and angle 8 that are all over here on this side. So angle 1, same position. I always kind of look at it as the upper left-hand angle here. Slide it over. Upper left-hand angle is going to be angle 3. So angle 1 and angle 3. Angle 2 would be corresponding with what angle? Angle 4. Upper right-hand angle. Angle 8 would be corresponding with what angle? Angle 6. You could have also had said angle 7 and angle 5. So now we're going to skip the got it, and we're going to go to problem 3, the section problem 3, under number 5, practice, on the top of page 657. You'll notice at the right that you have 6 angles, and you have ones that are labeled red. It looks like a darker, like red-black, and then a blue. So, are the angles labeled in the same color, alternate interior angles, same side interior angles, corresponding angles, or alternate exterior angles? So let's start with the red ones. So we're going to say angle 1 and angle 2, which are both red, are what? Let me actually make that readable. Well, angle 1 and angle 2 are on the inside, and they're on the same side of the transversal. So they would be same side interior angles. And remember, once again, as in proofs, you can abbreviate. The black/red ones, which kind of look black, we'll say angle 3 and angle 4. What do you think they are? Well, they're in the same position, so that means they're going to be corresponding angles. And then blue, which are 5 and 6. What do you think they are? They are also corresponding angles, angles in the same position.
Hi, this is Mrs. Evanchek. Your vocabulary is parallel lines, skew lines, parallel planes, transversal, alternate interior angles, same side interior angles, corresponding angles, and alternate exterior angles.
So your pop quiz tomorrow was who just read to you the vocabulary?